think is all about GPUs.
Yeah.
And then it's actually, in my opinion, more about networking, because it's not just one GPU. People have many GPUs that have to work together well. So it's essentially a network
coordinated to deliver the outcome.
Right.
So yes, that's why networking is actually a crucial piece.
Yes. See each other, there's an API contract, and Rafay would do a baton pass to Aviz and say, hey, where do we put this user? The server. And Aviz would do the job. It would know what's happening underneath.
Orchestration to really run it effectively. Part of it is because the resources are so expensive, you cannot afford downtime. You have to.
A regular CPU cloud is like your Toyota Camry. You press a button, it works, right? An AI factory is like your friendly Ferrari at Formula One, right?
Welcome everyone, and I'm really excited about today's conversation because we are talking about one of the most hottest topics, AI factories. Everyone is focused on GPUs, but building a successful AI factory takes much more than just powerful hardware. It takes orchestration, automation, observability, and an operating model that ties everything together. And joining me today are two leaders helping shape that future. Mohan Atreya is the Chief Product Officer from Rafay, where he leads the vision for AI infrastructure orchestration, platform engineering, and multi-tenant AI platforms that help organizations deliver GPU infrastructure as a service. Welcome, Mohan.
Thank you for having me.
And Thomas Scheibe is the Chief Product Officer at Aviz, leading the company's AI-native networking strategy, helping customers design, automate, and operate modern AI factories. Mohan and Thomas, welcome.
Great to be here.
Good to be here, Thomas.
Good to see you again.
Yeah.
So, everyone is talking about AI factories, but I would like to start from the beginning. What AI factory really is, and how different it is from the traditional data center?
Yeah. Maybe I could start, maybe you can add on to that. So the way I look at this is the operators buy the infrastructure, and it's not just GPUs, it's a bunch of switches, routers, storage, there's a whole lot of things that are set up underneath. And all this is set up in one or many data centers. And then they need multiple tenants on top to be able to consume from this unified infrastructure. What the users care about are things like, hey, give me a server with X GPUs, give me a virtual machine with Y GPUs, give me a Kubernetes cluster with 10 nodes with some GPUs and some with no GPUs. And it's not just one tenant. You may have like a Coke and a Pepsi or things of that kind. So multi-tenancy becomes a big problem, which I'm sure we'll talk about as part of the conversation. So therein lies a challenge for organizations. When you think about AI factory, it's not just the underlying data center, it's not just the infrastructure, it's a software stack that sits on top, and finally, the whole experience that you want to deliver to the customer. What would you like to add on to that?
No, this was great. I mean, I was like, I always think about it because I'm so long in the industry. It's like, so what is an AI factory, right? And I think the term factory seems to kind of indicate standardizing like production lines, right? And then I map it back to what it is. In my head, it's what is different to a data center, right? Data centers compute typically without GPU or maybe some GPU sprinkled in. Whereas here, an AI factory really is a GPU data center that runs everything that runs today in a data center on top of the GPUs, right? So, maybe because GPUs produce token are helpful for applications. So it's a token factory.
That's actually a fantastic
data
way.
center. That's the way I think.
Exactly.
Right?
So you kind of hit on something very, very interesting, the word factory, right? And I think that's maybe the most important part that sometimes gets glossed over, and thank you for mentioning that. I think standardization, being able to, this is a complicated distributed system. The last thing you want is for you to have a non-standard configuration and it works differently from a well-known configuration, and then you wonder why, right? And when you call it a factory, you get that consistency. So design that is in my data center works identical to the person next door, and that consistency is amazing, right?
No, it is. And where I was going with this, and that's I think, in my head, it's like, why wouldn't you just call it an AI cloud, right? Because if you think cloud computing was this don't worry about how to build it. It's just you rent your virtual computer instance or computer instance and move on, right? And so I think why I like factory more than an AI cloud, because it kind of really signals it's not a cloud only thing. You're going to deploy this in your own data center. It's just going to be an AI factory data center that operates like you would expect the cloud to operate, which I think we're going to come into, right? It's the standardization piece. So yeah, that's what when people ask me, so what's new about an AI factory? It's really a GPU standardized cloud running in an on-premises environment. It could be run as a cloud service, as we all know, but it's basically a modern data center.
Exactly. Yeah, the other thing, maybe it's kind of embedded in this whole thing, which I'm very sure we'll talk about. A lot of people think is all about GPUs. And when you have, it's actually, in my opinion, more about networking, because it's not just one GPU. People have many GPUs that have to work together well. So it's essentially a networking problem in the grand scheme of things. And doing that well is not easy.
You actually lead me just to my next two questions. So my first question is, everything that you mentioned, Thomas and Mohan, buying GPUs, making sure you have a software stack on top of it, standardizing AI factories that is standardized. What does it really mean for the customer? Buying GPUs is expensive. And how do you make, as a customer, how do you make these AI factories operational? So now that we understand what the AI factory really is, so how do you make it operational if you're an enterprise or a neo cloud?
So maybe I can start and we can add on. So the way I look at this, and as we work with many people who are operating this at scale, nothing is static. They are always adding servers, removing servers, adding data centers. It's something breaks, it has to get replaced. So it's a little bit of things moving around all the time. Normal day in the life of an ops person there. So half the problem they have is, how do they know when something goes wrong? They need to go and react to it, fix it, and if it's happening midway for a customer, they're having a problem upstream and they don't know that something has gone wrong. So that's that visibility and being able to take care of issues quickly, that becomes one problem. Second problem is, like we talked about, you have multiple tenants, Coke and Pepsi on top, as an example, that want to consume the infrastructure. How do I make sure that there's that there's a hard boundary between Coke and Pepsi? How do you slice this infrastructure into two chunks and make sure that there's never an overlap in resources between these two tenants? So that becomes a very important part. Then doing this manually is painful, especially when I have servers coming and going and the customer needs changing all the time. There has to be automation and orchestration. And this is where, I think this is an area where I think we have collaborated extensively. This problem and this challenge, I think we have heard again and again from our mutual customers, and we've kind of found a way to automate that. I mean, maybe talking about that from the lens of a customer, maybe you want to take a stab at that.
And I think you hit it, right? I mean, in the end, the factory, right? It's not just GPUs. That's why we don't call it GPU factory. We call it an AI factory because it's GPUs, CPUs, storage, networking to connect it all together. And then, in the end, you run the factory because you want to run workloads that produce outcomes. Right? And so to your point, which I really think is important, that is the more typical job how people think about infrastructure, monitoring, managing infrastructure. But we call it day zero. This is one set of the problem. The real second part is when you hand out capacity of your factory to tenants, right? And workloads, how do you dynamically scale up, scale down, increase capacity that you allocate to a tenant, or decrease when they don't need it, right? And so this is where the partnership really comes in, because if you look at what I think, well, we're a little bit selfish, right? Because we're the workload and networking team here. What you really care about when it comes to allocating capacity, somebody says, hey, tenant needs more capacity. Mohan says, yeah, take care of this. Tenant says, but better make sure my other neighbor doesn't see it. Thomas says, I will take care of that, right? I make sure the network will separate out the compute pool that gets mapped to this tenant from the compute pool that gets mapped to this tenant.
That's right.
So tenant, Pepsi or Coke, using the US term versus the tenant red wine and white wine in Europe, you cannot talk, right? And so this is where really I think where the gist is, that dynamic scaling up, scaling down of resources in a secure and safe way for tenants is where we really deliver a combined value.
Yeah, it might be worth double clicking on the networking thing a little bit. It's not one network. Let's just double click on that to keep it simple. The GPUs have to talk to each other. That's usually called the east-west network. And they talk very fast with no latency. That's one network. Then the end user needs to access their resources, and that is usually called north-south, like a tenant access network. And then you have also your resources may need to talk to a storage system. There's a storage network. So there's a lot that has to get orchestrated, and a lot of things have to be managed. It's a complex distributed environment, and doing this manually is just impossible. You will make mistakes, and disastrous mistakes. So automation is your friend here.
The only comment to make, AI factories warm my heart as a networking person, because it used to be we had 2 or 3 networks max, out of band, storage dedicated. Some people might remember these fiber channel things. And then we had Ethernet. AI factories have at least 5 networks, and they all have to be coordinated to deliver the outcome. So yes, that's why networking is actually a crucial piece.
So networking suddenly became so important. It's just, even maybe a couple years ago, nobody really wanted to talk about networking, and now it's such a critical part of the AI infrastructure. So it leads me to the next question. I wanted to ask you and maybe explain a little bit better to our listeners here where Rafay actually fits and where Aviz fits, and how does it all come together. I know we slightly touched on that about our partnership, but I would like to go a little bit into more detail. How does it all fit together as an operating model?
So maybe a good way to think about this, let's use an example. Let's say I'm a user in a certain tenant. I've logged in and I come and said, hey, give me a server with 8 GPUs.
So if I'm the customer and I'm building either AI factory or I'm renting GPU, so I submitted the request for GPU resources, right? So what happens next?
So exactly. So usually a customer, an end user, asks for these in the form of a server or a virtual machine, as in the GPUs live inside one of these, let's call them containers, right? So let's say I asked for a server and I said, hey, give me a server with 8 GPUs. Or maybe multiple servers for that matter, right? So now what Rafay would do is say, great, I can give you that, but where am I going to allocate you? Because I have a pool of resources. It may span multiple data centers. And let's say you ask for an H100 GPU based server. So I'm going to go look at the inventory and come and say, hey, in this data center, I have a server that I can allocate you. And so I now go and say, hey, this from the inventory, take it and give it to this user. Now, I'm not just giving a server. It has to be a server with a certain operating system. So now we have to, on the fly, wake it up and install an OS in it. Let's say it's Ubuntu 24.04. I install the OS. Now, usually it's not just that. People say, hey, look, I don't want to go and just get an OS and install all 50, 60 libraries. It's very painful. So can you just give me a ready-to-use system with all the tools and everything in it? So now we have to install all those things as well and get it as close as possible to the finish line. Now, the user cares only about that, but they also said, I need this in my VPC, in my network, right? Now, as Rafay, we don't know too much about the network underneath. We basically say, take this server and install all these things, but the server now has to be pivoted into a network that is being managed. In our case, Aviz manages that network, and it knows that. So this is where a programmatic integration between the two platforms has been very powerful, because there's no human being responding to ServiceNow tickets or manual ticketing process. The system kind of talks to each other. There's an API contract, and Rafay would do a baton pass to Aviz and say, hey, where do we put this user, the server? and Aviz would do the job. It would know what's happening underneath us, and he would orchestrate that particular thing and move that server into the right tenant's VPC, and then come back to us and say, okay, here you go, here's your server. So it's in a way, it's a clear distribution of responsibilities where we take care of a few things that we are good at, and then we pass it on to Aviz, which takes care of what it does really well. And that partnership works out well for our customers.
That's awesome. Thomas?
This was great. I don't know much to add. The only thing which just dawned on me, we use the term VPC, which is actually a cloud term, which stands for Virtual Private Cloud. In the AI Factory, we really should rename this in VPF, Virtual Private Factory, because in the end, that's really what we're doing, right? To your point, the way you described it, you as a tenant, you want your own virtual private factory, right? Which is, build me a logical construct that only I have access to. Whatever compute you provision, make sure that Aviz makes sure nobody else can connect to that compute that is not part of my virtual private factory. So that's really what we're doing. And so it takes the bringing up not only the compute, but then bringing up the OS and whatever else the user want on top of it, which you can take care of. And then it takes the connecting to whatever else you have in your virtual private factory. I like the term, actually. And make sure you connect it properly. And that's the networking aspect, right? Networking in the literal sense of connectivity is there.
No, actually, it's a very good point you made about the term VPC. And you'd see a lot of us kind of gravitating to those cloud terms. And there's a reason for that. For the last 20 years, users have been trained by the hyperscalers. So we've just kind of started reusing terms like VPCs because it's just natural for them to understand that. It's perhaps with this new wave, maybe there's an opportunity to reinvent these terms.
I think they are fine, right? Because I do actually think, I used to use this term in the past, what really customers or users of these factories want, they want a cloud operations model, which really doesn't mean it has to run in a hyperscaler. What they want is the self-service. I want this compute node with that kind of GPU, click, and it should get provision as long it's within the budget.
Exactly.
Right? And so that's what most people understand and got used to and see as a cloud operations model, right?
Yes.
Self-service as a catalog. You click what you want, you're going to get it automatically provisioned.
Yes.
And that's basically what we're doing in an AI factory.
Exactly.
Right?
Exactly. So,
So from the customer perspective, when everything is in action, what do you think surprises the customer the most from the value perspective?
I think what I shouldn't say surprises them. I think they have this minimum expectation. Like I said, they've been trained for 20 years to expect a hyperscaler-like experience. So if I'm a neo cloud or if I'm an enterprise, and I go tell my users, consume from this pool of resources, they expect you to be that tall, right? That's become like table stakes. So unless you have that level of automation and orchestration, in my opinion, as a user, it's very hard to live with something that's clunkier. Which is actually good because we are starting with the baseline that's pretty good. It's natural for a user to, it's so consistent, right? Like what I used to experience in my hyperscaler, I get something similar in this neo cloud or enterprise. There's a higher chance of adoption and faster adoption because it's so seamless. It's not like a strange new thing for the user.
And from your point
of view, again, I mean, I sometimes say this, like, to me, this is very much what compute used to be, the cloud compute. Now it's just GPU cloud compute. And the behavior and the experience that a user wants is the same, right? What needs to happen under the hood, and this is where the combined value comes in, GPU-based compute just requires way more orchestration to really run it effectively. Part of it is because the resources are so expensive, you cannot afford downtime. You have to make sure the coordination between multiple compute nodes, GPU nodes, is really properly done. Because you really want to get ideally to 90% plus utilization instead of what typical compute clouds I am aware of is much lower. And you just can't afford this given the cost of your assets. So having that end-to-end orchestration automation is what everybody expects. And in this particular case, I think you really have to deliver on that to actually make the business case work and really get the last drop of juice out of this.
Yeah, absolutely. Maybe another way to think about this from a money perspective, one common thing you'd hear from customers is, hey, the hyperscalers cost a lot more for the same GPU. How come it's cheaper on a neocloud, as an example? And the answer should not be that, well, we do automation poorly, and therefore we charge you less. That would be a bad way to articulate the value prop to a customer. If they can be as tall as a hyperscaler, and then deliver a very high SLA, because that's kind of what you're trained to get in a hyperscaler. Can you get something similar? And to do that, you need the right technology stack and the right technical choices made underneath, and the right level of automation so that you can deliver that kind of an experience. So what I would tell neoclouds and others is do the right kind of automation so you can command a higher premium for the same service, right? Otherwise, you're just going to have unhappy customers.
Very well put.
That's right. So how about just one question came to my mind as a fun question. So if you are in the control room of an AI factory, for example, what is one alert that you would never want to see?
One alert you never want to see.
Yeah.
Or
oh wow, put a positive spin is 10% utilization. Clearly you don't have enough tenants.
Yeah.
But that's not, I think, what you're asking for.
Yeah.
I think it's like any other IT infrastructure, right? I mean, what you're watching for is clearly utilization. You're looking at, since we're talking GPU world, you're looking at token efficiency across the GPU estate. I think you're looking about any failure scenarios, whether it's service going down, network links having issues, transceivers having issues, whatever it might be. And then it really just comes back to user experience, right? Because in the end, like any control room, you're monitoring your service level objectives and trying to minimize any downtime. And I'm not talking about downtime in the traditional sense, more application performance impacting downtime, right?
Yeah.
And so, I think in that sense, I don't think there's really anything that different, right? The difference really is the tools need to adjust to make sure you can actually monitor the right things in a GPU-centric world. And I say this on purpose because there's still everything else. You still need to monitor the network, you still need to monitor the storage, you still need to monitor your transceivers, you still need to monitor your standard server stuff, right? Fans, power, all of that you have to do the same way. But you have to overlay now all the GPU-centric metrics as well to actually have a good answer.
Yeah, I think just to add to that, just hearing you talk about it reminded me of maybe a really bad example that I would never want happen if I were an enterprise or a neocloud. There are issues that are obvious to detect, and then when they happen, you can quickly respond and fix it. Like replacing a GPU, giving another server, things are black and white. There are some issues that fall in this gray zone. And the fun one I've seen is like a network flapping. And those things are crazy because you don't know if it's a deterministic issue or will it kind of recover, and you don't know if I had to change something or even debug it. I'm sure you guys have seen this, given you guys live in the networking world. It's a painful process for customers.
There's a term actually for it. It's called gray failure. Is when it's really not black and white and you're trying to figure out what's going on. So yes, and very well understood problem, and it comes down to having the right metric, right? Because you don't want to see flap and don't know what's going on. Typical expectations are you actually shut down and fail over instead of trying to recover. But absolutely. This is one of those. You want to be able to have the right set of data.
I think the key message is there are traditional CPU environments that are easier. And GPU-based AI factories are different. And they're not as simple and straightforward as the older systems that they were used to. So I would say, hey, Mr. Customer, just be careful. understand what you're getting into, and have the right tools and platforms to support you through the process.
Yeah, so I would love actually to get a piece of advice from each of you to customers that are just starting with AI factories. What do you recommend they do? What is the most important part?
Yeah. Let me maybe take this one, and I want to actually extend to the previous one, and that I think goes there.
Go for it. Yeah.
Because if you look at an AI factory thing, it's really standardized data centers around GPU type compute operating like a cloud, right? If you start with there, you should just, all the things you learned in the past should apply. How do you standardize blueprints? How do you bring stuff up so you don't have a lot of what we call nerd knobs built in, because it's very hard to automate, right? All of these things apply. Fortunately enough, we all work off reference architectures and we standardize blueprints, how to deploy this. Operationally, all the same things apply, which you would have monitored in the past, like your main infrastructure, network, compute, storage, application, all of this applies. The additional wrinkle that you really need to think through in an AI factory, you actually don't just run the app on a CPU and you'd be happy. You actually, what you do is you have something like an LLM or a VLLM that then exercises one or multiple GPUs. You have that two-layer piece in the middle, which is LLMs and GPUs. And if you really want to talk about application experience and trying to figure out how that relates to your infrastructure, you need to be able to stitch together infrastructure behavior to application behavior across these two things in the middle, which is LLM metrics and GPU metrics. So that's the piece you really want to either understand or bring somebody in that understands. Speak Rafay and Aviz, because that is the mapping that needs to happen, right? Because in the end, it's like the app is not working well because token efficiency is a problem. You're trying to figure out why token is a problem. And then maybe that is because GPU routing doesn't work properly. And then you come back to, that's on the server, right? These two pieces in the middle are the new ones, and that's really what I think you need to understand really, really well from a monitoring instantiation perspective, because if you don't know how to measure that properly, you will never get a good answer on why your factory doesn't work.
Exactly. So, I think it's a good one. To simplify that, maybe, here's kind of what I would suggest. A regular CPU cloud is like your Toyota Camry. You press a button, it works, right? An AI factory is like your friendly Ferrari at Formula One, right? It has to be tuned and optimized, then it'll perform really well. And it does certain things amazingly well, but if done well. So what I would suggest anyone who is looking at getting into the space is there's more to it than meets the eye. Do your homework. There are well understood, documented reference architectures which eliminate and reduce business risk. Employ that. If it is new to you, go with vendors who kind of played in the space, have the scar tissues where they learned from previous engagements where you would not be the guinea pig for them, and
you cannot
move
afford
fast.
To be a guinea pig, right?
Exactly, right? I think that those are it's so simplistic in some ways, but as long as you know that it's not trivial, acknowledge it and reduce your business risk as you go along to the extent you can. That's what I would suggest anyone getting into the space.
No, very well summary. And reducing risk is always standardize, automate, and have a proper set of toolings that goes end to end.
Exactly.
I think that's really what we deliver together.
Yeah, exactly.
And just to finish our conversation of, AI infrastructure is changing so fast. So if we have this conversation in 2 years, how do you think AI factory will look like?
You want me to take this?
Go start. I have an opinion, but go start.
So we guys are starting to see some planning for designs that are absolutely mind-blowing. Gigawatt scale, people having multiple data halls. I know we haven't even talked about data halls yet. And everything is a rack. We all think in servers. Imagine there's no more servers. Everything, the atomic unit now is a rack. And you have multiple racks comprising a data hall, and you have multiple data halls. The failure domain changes. We talked about failure domains that are maybe more reminiscent of a server and a distributed network, in this case, is different. This is the new way in which the larger environments are going to be set up. And these guys are starting out with 10,000 GPUs, 20,000 GPUs, at least building for that, right? That's what adds up to a gigawatt. So these are going to be at a scale that's just very different. How do you scale up to these? What are the things our software has to evolve to support this kind of scale? This is what the new world is going to look like in a couple of years. I mean, these guys are planning for this. It's not going to happen in 2 months. It's going to happen in 6 months, and maybe at scale in a year or so. But that's a new world. So forget server-grade systems. Racks are going to be the norm, and data halls are going to be the norm. And the failure domains, you got to think differently now. What is this going to manifest like across the board? Is everyone going to look like this, or only a few people are going to start there? That's the million-dollar question. Right. Because it's a different level of complexity. But this is coming.
This is coming.
Yeah. I actually think, yes, there's going to be a lot of evolution and new technology waves, right? It used to be every 3 years. Now a new GPU version comes every year. A new LLM comes every week. But I think the operational principles, right, the cloud operational principles applied to AI factories, they are not changing. Actually, if I look at this, what we're designing for right now, it's in a sense very, very similar how large compute clouds, hyperscalers, run their networks and their infrastructure. Clear separation between tenant, compute, and infrastructure. Right, there's the discussion around what do I run on the front end NIC, the DPU. How do I make sure I have a clear security zone, trust zones between my infrastructure and the tenant domain? I think if we longer stick with that model and actually automate around that, I think all the technology innovation that will come in this space, at least from what we see so far based on roadmaps, will fit in actually really, really nicely. It comes down to, thinking more around failure domain or availability zone, to use a cloud term that everybody knows, right? It's all around what are compute nodes defined, right? Is it a server with 8 GPU or is it a rack with 72 GPUs or going forward maybe 256 GPUs?
Yes.
Right? The building blocks, the Legos might change color and shape, right? Some cloud provider calls it actually shapes. But the model, the operational model, what we are really after, how to help our customers around, how do you orchestrate compute, and then the network needs to go with it. The principles will be, I think, very constant based on what I have observed over the last 20 years in the space.
Absolutely.
So we actually, I think we're pretty comfortable.
Yeah, exactly. Maybe, and just to add on to that, maybe why are people building all this capacity, right? Because the way, in a couple of years, I think AI is going to be pervasive. Today we live in a world where there's a non-AI app and an AI app, a non-AI workflow, an AI workflow. Why does it have to be non-AI at all? Why does it even make sense? It doesn't even have to be AI assisted. It has to be AI native. That's a new world, but we are in this transitory period as we go there, and all of this is going to, generate crazy amount of demand, which is the premise behind all these gigawatt scale deployments that are going on. It takes time to build infrastructure.
And it's amazing how the world evolved so fast. Just 2 years ago at the conferences, people were very reluctant even to hear about AI, and now it's like AI is here for sure.
Exactly.
Well, Thomas, Mohan, thank you very much for joining the podcast. It's been great to have you here. I really enjoyed this conversation because I think we moved beyond just individual technologies and talked about what it really takes to build the AI factory. So thank you for coming and hope to see you again next time.
Thank you. Thank you for the opportunity.
Thank you.
Thank you
I appreciate it.
Thank you,
Thanks
Thomas.
as always.
Pleasure. Yeah.